Good day, everyone. This is the report of Team Benedictus, which is Chapter 5 entitled Solving Integration Problems Using Patterns.
So, good morning classmate and our teacher, Sir Peña. So, i-discuss ko yung middleware. So, recap lang to kasi na-discuss na nila Kuya Jomar. So, ano nga ba si middleware? Middleware is a software that facilitate communication between two or more software system. So, si middleware ay isang uri ng software na nagpapabilis sa communication sa pagitan ng dalawa o higit pang system software. So, we have also the message-oriented middleware or MOM. This is another of middleware in which the communication between the various distributed application is made through the medium of messaging. MOMs utilize a message provider that enable to various applications to communicate and exchange data by sending and receiving message. So, si MOMs naman ay isang uri ng software or hardware infrastructure na sumusuporta sa sending and receiving message bago ipamahagi sa iba't ibang system or platforms. So, we have a video to explain or show how the middleware interact each other or connected each other.
Hello, today we're gonna introduce you about the middleware. So, what is middleware? Basically, the middleware is a software glue. It is kind of like plumbing, which connects the pipes together in your sink or the bathroom. Connects different areas of the house. Middleware is a link between separate software connecting your computer, smartphone, and credit card, for example. Still confused? Let's break it down even further. Middleware provides services to software applications beyond those provided by operating system. It facilitates these functions. Middleware is invisible. It's hidden between operating system and software applications. It connects all these devices. Much like plumbing connects all kinds of areas in your home.
We have also the two types of coupling. Each one is tight coupling and loose coupling. Si tight coupling is a coupling technique in which hardware and software components are highly dependent on each other. It is used to refer to the state or intent of interconnectivity between two or more computing instances in an integrated system. Tight coupling is also known as high coupling and strong coupling. So, si tight coupling naman ay isang pamaraan sa pagkabit kung saan yung bahagi ng hardware or software ay umaasa sa bawat isa. So, si loose coupling is describe a coupling technique in which two or more hardware and software components are attached or linked together to provide two services that are not independent on each other. This term is used to describe the degree and intent to interconnected but not independent component within an information system. Loose coupling is also known as low and weak coupling. So, si loose coupling naman ay isang paraan ng pagkabit kung saan dalawa o higit pang bahagi ng hardware or software na magkadikit or linked together or connected para ipamahagi yung dalawang serbisyo o service na hindi umaasa sa bawat isa. So, I have also the example, the two types of coupling.
Illustration for something called coupling. There are two types of coupling, tight coupling or loose coupling. For example, the cannonballs that are custom made for a custom made cannon are tightly coupled to that cannon, whereas Jean-Baptiste's loosely coupled cannon design will allow you to exchange the cannonball inventory without any conflict. But the cannonball example is a fairly crude simplification. Carl Weick, the one that came up with this coupling concept, wrote about more intangible systems like organizations and information systems. He discovered that tightly coupled systems run very smoothly when all the steps in the system are present and accounted for. But these types of systems are fragile to any change, like bumping one domino and having the rest of them fall. Understanding coupling comes in really handy when you're setting up a system to turn data into information. Let me give you a few common examples of tightly coupled scenarios which we often see in this space. So first example, let's say you have a data guy that gives you all the information you need. Well, this means that you are tightly coupled to that data guy. The day that analyst finds a new job is the day you stop getting information. The more that data guy uniquely supplies and understands your organization's data, the more painful his or her exit is. Second example, your organization decides to custom build all the analytics into the CRM or ERP application. This means that you are tightly coupling yourself to your software vendor because all your information assets are custom coded therein. So when you go to negotiate your fees with your vendor, you no longer have the upper hand. Or worse, if you have to replace that vendor, you now are forced to completely rebuild how do you turn data into information. Third example. Imagine your organization needs to change the way it calculates its cost. This will require you to change some logic in your analytics. However, since you already have thousands of reports and analytics, you need to be sure that change is accounted for across all of them. There's only one problem. The solution you chose for data visualization nests the SQL query logic in the data visualization itself. So now you have to open each one individually, edit the SQL, and repeat 1,000 times because the visualization and the query logic are tightly coupled together. Fourth example, each night you load data into a data warehouse to supply analytics to your business. However, one particular night, the load takes too long. So now it's running during the day and your users can't even query the data warehouse because its computing power is being tied up with loading data. So in this case, the compute and the storage are tightly coupled together. So you just have to wait until you can get access to that data again.
Tight coupling example assumptions. This minimalist integration solution is fast and cheap, but it results in very brittle solutions because the two participating parties make the following assumptions about each other. Platform technology. Internal representation of numbers and objects. 32-bit versus 64-bit internal representation. A system using 64 bits would be inclined to read 8 bytes of the network and would end up interpreting the whole message, including the customer name in a single number. Location. Hard-coded machine addresses. Remote functions and machine location are hard-coded. Any change in anything, we would have to change code. If we use a lot of remote functions, this would become very tedious. Time. All components have to be available at the same time. Establishing a TCP connection requires that both machines and the network are all available at the same time. Data format. The list of parameters and their types must match. If we want to insert a third parameter, example, the name of the currency, we will have to modify both sender and receiver to use the new data format. Coupling is a measure of how many assumptions parties make about each other when they communicate, or our simple solution requires the parties to make a lot of assumptions. Therefore, the solution is tightly coupled. Loosely coupled solution. Instead, we can develop loosely coupled solution by using message-oriented middleware or MOM infrastructure. MOM mechanisms provide services such as a common data format and transformers, Removes platform and data format dependencies as the sender no longer has to depend on the receiver's internal data format. Queuing channels. Removes location and the time dependencies as we do not to pay attention to computer's identity and location, or whether the other computer is ready to accept requests or not. Removing these dependencies between the systems make the overall solutions more tolerant to change. The key benefit of loose coupling.
Continuation of the discussion. Things that make up middleware. So, as we mentioned earlier, middleware is the things that sit between applications. So, in order to connect two systems by an integration solution, a number of things have to happen. So, applications want to exchange data messages. So, what is messages? Messages is a snippet of data that has an agreed upon meaning to both applications that are to be integrated. So, this piece of data can be very small, such as the phone number of a single customer that has changed, or very large, such as the complete single customers and their associated addresses. Move on to the message construction. So when two applications wish to exchange a piece of data, they do so by wrapping it in a message. So first is the message intent. Under this is the command message, document message, and event message. So first, what is command message? Command message invoking a function or method on the receiver, while document message enabling the sender to transmit one of its data structures. Event message notifying the receiver of a change in the sender. So next is the returning of a request. Under this is the request reply, return address, and correlation identifier. So what is request reply? The request is usually a command message, and the reply is a document message containing a result, value, or an exception. While return address means the requester specifies that what channel to use to transmit the reply. And last is the correlation identifier. Responder specifies which request this reply corresponds to. So the third one is the huge amounts of data. Under this is the message sequence, and the slow message is the huge amounts of data. Under this is the message sequence. So what is message sequence? Message sequence break the data into more manageable chunks and send them as a sequence of messages so that the receiver can reconstruct the original data structure. So the last one is the slow messages. Under this is the message expiration. So message expiration, the sender can specify an expiration date. If the messaging system cannot deliver a message by its expiration, it should discard the message. If a receiver gets a message after its expiration, it should discard the message. This is the third one. Things that make up middleware using channel. So data needs to be transported usually across a network. So we need a communication channel that can move information from one application to the other. So this channel could be a series of TCP/IP connections, a shared file, or a shared database. So what is channel? A channel is a logical address that both sender and receiver can agree on the same channel without being aware of each other's identity. And next is the messaging channel. So we have 9 messaging channels here. The first one is the point-to-point channel. So to send the data to a single application. So it means one-to-one interaction. Next one is the publish subscribe channel. So when you send a piece of data this way, the channel effectively copies the data for each of the receivers, meaning to say one to more interaction. Third one is the data type channel. All of the data on a channel has to be the same type. It means many to one interaction. So fourth one is the invalid message channel. When receiver receives a message that doesn't meet these expectations. Fifth is dead letter channel. For messages which are successfully sent but ultimately cannot be successfully delivered. The sixth one is the guarantee deliver makes channel persistent so that their messages are stored on disk. Seventh one is the channel adapter. Can be used to connect a channel or a set of channels to the application without having to modify the application. The eighth one is the message bridge. Connecting two message systems, effectively connecting them into one composite messaging system. The last one is the message bus. Message bus is a backbone providing access to all of the enterprise's various and ever-changing applications and functionality.
Things that make up middleware translation. Bago tayo magpatuloy, ano nga ba si middleware? What is middleware? Ang middleware ay isang software na kumikilos bilang isang tagapamagitan sa pagitan ng dalawang application o service upang mapadali ang kanilang communication. Maaari mong isipin to bilang isang proxy na maaaring kumilos bilang isang data accumulator, translator, o isang proxy lang na nagpapasa ng mga request. Common use cases for middleware, isa na dyan na yung translator, one of the things that make up middleware. Maraming mga format ng pagpapalit ng data tulad ng JSON, XML at protobuf. Even though we mostly use JSON nowadays, each of them have their own use cases. For example, ang mga protobuffer ay kilala na mas performant kaysa kay JSON, but they are not human readable. So, maaaring gumagamit ka ng mga protobuffer para sa internal services at maaari mong gamitin ng JSON kapag ang API consumer ay isang browser. Now, let's say we need these two services na nagsasalita sa iba't ibang mga protocol upang makipag-usap sa bawat isa. Pwede tayong mag-create ng isang middleware na gumagamit ng isang library ng conversion ng data at i-translate ang mga request sa isang format na kung saan ay mauunawaan ng receiver o yung tumatanggap ng service. So, in other words, we can compare middleware to a translator helping people who speak different languages to understand each other. When it comes to things that make up middleware needs to provide some mechanism to convert one application's data format in the others. So, meaning to say, ang middleware ay kailangan niyang magbigay ng ilang mechanism upang ma-convert ang format ng data ng isang application sa iba pa. Ang internal na format ng data ng isang application ay madalas hindi nagbabago. For example, ang isang format ng data ay maaaring mag-store ng pangalan ng customer sa dalawang field na tinatawag na first name and last name, habang ang ibang system ay maaaring gumamit ng isang solong field na tinatawag naman na pangalan ng customer. Message transformation. As described in message translator, ang mga application na kinakailangang isama ng isang messaging system ay bihirang sumasang-ayon sa isang karaniwang format ng data. For example, An accounting system is going to have a different notion of a customer object than a customer relationship management system. On top of that, ang isang system ay maaaring magpatuloy ng data sa isang relational model, while another application uses flat files or XML documents. Integrating existing applications oftentimes means that we do not have the liberty of modifying the applications to work more easily with other systems. Rather, the integration solution has accommodate and resolve the differences between the varying systems. The message translator pattern offers a general solution to such differences in data formats. Message transformation. As described in message translator, ang mga application na kinakailangang isama ng isang messaging system ay bihirang sumasang-ayon sa isang karaniwang format ng data. For example, an accounting system is going to have a different notion of a customer object than a customer relationship management system. On top of that, ang isang system ay maaaring magpatuloy ng data sa isang relational model, while another application uses flat files or XML documents. Integrating existing applications oftentimes means that we do not have the liberty of modifying the applications to work more easily with other systems. Rather, the integration solution has accommodate and resolve the differences between the varying systems. The message translator pattern offers a general solution to such differences in data formats. Karamihan sa mga messaging system ay naglalagay ng mga specific requirements sa format at nilalaman ng isang message header. We wrap message payload data into an envelope wrapper that is compliant with the requirements of the messaging infrastructure. Multiple envelope wrappers can be combined if a message is passed through across different messaging infrastructures. A content enricher is needed if the target system requires data fields that the originating system cannot supply. It has the ability to look up missing information or compute it from the available data. The content filter does the opposite. It removes unwanted data from a message. The claim check also removes data from a message but stores it for later retrieval. The normalizer translates messages arriving in many different formats into a common format. Message transformation is a deep topic in integration. Ang message channels at message routers ay may kakayang alisin yung mga pangunahing dependency sa pagitan ng mga application by eliminating the need for one application to be aware of the other's location. Ang isang application ay maaaring magpadala ng isang message sa isang message channel and worry about what application will consume it. However, message formats impose another set of dependency. Kung ang isang application ay kailangang mag-format ng mga message sa format ng data ng isa pang application, the decoupling in form of the message channel is somewhat of an illusion. Any change to the receiving application or the switch from one receiving application to another still requires a change to the sending application. Message translators help remove this dependency due to the importance of message formats and transformation between them. We can view any integration solution as two parallel systems. One deals with actual message data, the other one with metadata, the data that describes message data. Many of the patterns used in creation of the message flow can also be used to manage metadata. For example, a channel adapter can not only move messages in and out of a system, but it can also extract metadata from external applications and load it into a central metadata repository. Using this repository, the integration developers can define transformations between the application metadata and the canonical data model. For example, this image depicts the integration between two applications that need to exchange customer information. Each system has a slightly different definition of customer data. Application A stores first and last name in two separate fields, whereas application B stores it in one field. Likewise, application A stores the customer zip code and not the state, while application B stores only the state code. Messages flowing from application A to application B have to undergo a transformation so that application B can receive data in the required format. Creating the transformation is much simplified if the channel adapters can also extract metadata, for example, data describing the message format. This metadata can then be loaded into a repository, greatly simplifying the configuration and validation of the message translator. The metadata can be stored in a variety of formats. A common format used for XML messages are XML schema definitions. Other EAI tools implement proprietary metadata formats, but allow administrators to import and export of metadata into different formats. Many of the principles incorporated in these patterns are applicable outside of messaging integration. For example, file transfer has to perform transformation functions between systems. Likewise, remote procedure invocation has to make requests in the data format specified by the service that is to be called even if the application's internal format is different. Things that make up middleware routing. Ang middleware ay kailangan niyang mag-ingat sa pagpapadala ng mga message sa maraming mga system. As the number of systems increases, it becomes very tedious and requires the sending system to have knowledge about all other systems. Halimbawa, kung nagbago ang address ng customer sa customer care system, maaari nating gawing responsable ang system na yon para sa pagpapadala ng data sa iba pang mga system na nag-i-store ng kopya ng address ng customer. Maaari nating asahan ang bawat application na tukuyin ng mga target na system para sa data na ipinapadala nito sa channel. Message routing. Now let's describe variations of data transformation tasks. It does not go into the details of structural transformations between entities. For example, how do you transform between two data models if one model supports many-to-many relationships between customer and address, but the other model includes address fields on the customer record? Let's elaborate the specific types of message routers to explain how to provide routing and brokering ability to an integration solution. Most patterns are refinements of the message router pattern, while others combine multiple message routers to solve more complex problems. Therefore, we can categorize the message routing patterns into the following groups. Simple routers are variants of the message router and route messages from one inbound channel to one or more outbound channels. Compose routers combine multiple simple routers to create more complex message flows. Architectural patterns describe architectural styles based on message routers. Simple routers. The content-based router inspects the content of a message and routes it to another channel based on the content of the message. Using such router, it enables the message producer to send messages to a single channel and leave it to the content-based router to inspect messages and route them to the proper destination. This alleviates the sending application from this task and avoids coupling the message producer to specific destination channels. A message filter is a special form of a content-based router. It examines the message content and passes the message to another channel if the message content matches certain criteria. Otherwise, it discards the message. Message filters can be used with publish-subscribe channel to route a message to all possible recipients and allow the recipients to filter out irrelevant messages. A message filter performs a function that is very similar to selective consumer, with the key difference being that a message filter is part of messaging system, routing qualifying messages to another channel, whereas a selective consumer is built into a message endpoint. Things that make up middleware routing. Ang middleware ay kailangan niyang mag-ingat sa pagpapadala ng mga message sa maraming mga system. As the number of systems increases, it becomes very tedious and requires the sending system to have knowledge about all other systems. Halimbawa, kung nagbago ang address ng customer sa customer care system, maaari nating gawing responsable ang system na yon para sa pagpapadala ng data sa iba pang mga system na nag-i-store ng kopya ng address ng customer. Maaari nating asahan ang bawat application na tukuyin ng mga target na system para sa data na ipinapadala nito sa channel. Message routing. Now let's describe variations of data transformation tasks. It does not go into the details of structural transformations between entities. For example, how do you transform between two data models if one model supports many-to-many relationships between customer and address, but the other model includes address fields on the customer record? Let's elaborate the specific types of message routers to explain how to provide routing and brokering ability to an integration solution. Most patterns are refinements of the message router pattern, while others combine multiple message routers to solve more complex problems. Therefore, we can categorize the message routing patterns into the following groups. Simple routers are variants of the message router and route messages from one inbound channel to one or more outbound channels. Compose routers combine multiple simple routers to create more complex message flows. Architectural patterns describe architectural styles based on message routers.
Integration solutions can quickly become complex because they deal with multiple applications, data formats, channels, routing, and transformation. In order to have any idea what is going on inside the system, we need a system's management functions. These subsystems monitors the flow of data, make sure that all applications and components are available, and reports error conditions to a central locations. Control bus provides a single point of control to manage and monitor a distributed solution. Next, detour messages through additional steps such as validation or logging, with ability to switch on or off these additional steps. Next, wiretap inspect the contents of a message without affecting the primary message flow. Next, message history. Great aid to know where a specific message has been. Next, message store. Can provide a complete account of every message that traveled through the systems. Next, smart proxy. Track messages sent to request reply services. Next, test message. Actively verifying that the running messaging system is functioning properly. And the last, channel purger. Remove all remaining messages from a channel so that the components under test do not receive leftover messages. Most package and legacy applications and many custom applications are not prepared to participate in an integration solution. We need a message endpoint to connect the system explicitly to the integration solution. The endpoint can be a special piece of code or a channel adapter provided by an integration software vendor.
So here are the concepts in terms of endpoints. First is messaging gateway, a class that wraps messaging specific method calls and exposes domain specific methods to the application. Next is messaging mapper, creates a mapping logic between the messaging infrastructure and the domain objects. Next is transactional client, make the client's session with the messaging system transactional so that the client can specify transaction boundaries. Next is calling consumer. This explicitly makes a call when it wants to receive a message. Next is event-driven consumer. It automatically handles messages as they are delivered on the channel. Next is competing consumers. It creates multiple consumers on a single channel so that the multiple messages can be processed concurrently. Next is message dispatcher. It consumes messages from a channel and distributes them to the performers. Next is selective consumer. It filters messages delivered to a channel so that it only receives the ones that match its criteria. Next is durable subscriber. to make the messaging system save messages published while the subscriber is disconnected. Next is idempotent receiver. It can safely receive the same message multiple times. And the last is service activator. It connects the messages on the channel to the service being accessed. So to be able to understand the message-based integration, here is the widgets and gadgets are us. This is an online retailer that buys widgets and gadgets from manufacturers and resells them to customers. So here is the ecosystem of the WGRUS. We have, of course, the retailer, the widgets and gadgets are us, the customers, the suppliers, and the shipping. So here is the IT infrastructure. So the widgets and gadgets are us have different channels, 4 different channels to interact with the customers. They can visit the company's website, call the customer service or the call center, and they submit orders by fax or the inbound fax. And then they can also receive notifications via email, which is the outbound email. So that is the customer's preferences to order in the WGRUS. So, the right side naman, the widgets and gadgets are us internal system are comprised of the accounting system, which also includes the billing functions, the shipping system that computes shipping charges and interacts with the shipping companies, and it has 2 inventory and catalog system.
Requirements business process. Take order. Take orders, customer can place order via web, phone, or fax. So sabi na po dito na maaaring order sa customer through website or pwedeng telepono para makapag-order sila ng gusto ng order. Process orders. Process order is a processing and ordering multiple steps including verifying inventory, shipping the goods, and enclosing the customers. Sabi lang po, ang pagproseso ng isang order ng isang nakasangkot ng inventory na maraming hakbang kabilang ng pag-invent, ang pag-verify ng inventory nila para mapagbigay ng information about sa in-order ng customer. Check status. Check status. Customer can check the order's status. Yan po. Pati na paliwanag. Maaaring suriin ng customer yung in-order niya. Kung mayroon bang damage, kung tama ba, kung tama ba yung mga information niya na binigay. Change address. Change address. Customer can use web front end to change their billing and shipping address. May karapatan na baguhin ng isang customer yung kanyang information, kung may mali ba, kung may tama ba, kung may hindi bang magandang nailagay or kung maayos ba yung ginawa niya. New catalog. The suppliers update their catalog periodically, needs to update its pricing and availability based on their new catalog. Yung mga supplier, panapanahon na binabago yung kanilang, ina-update yung kanilang catalog upang makapag-proseso at ma-avail ng batay sa kanilang mga bagong catalog. Announcement. Customer can subscribe to selective announcement from WGRUS. Maaaring mag-subscribe ang customer sa piling pagpapahayag mula sa in-order nila website. Testing and monitoring. Testing and monitoring, the operation of staff needs to be able to monitor individual components and the message flow between them. Yung kailangan makasubaybay yung mga tauhan sa operasyon para ibahagi yung daloy ng mensahe sa magitan nila kung tama ba yung binigay nilang information sa customer o use ba yung pag-order niya. Take orders and process orders. O yung dalawang pag-take ng mga orders. Pero kung tayo sa taking orders para mapaliwanag ko ng maayos. Take orders. Hindi po nakapalog yung ordering via web or form. Papansin naman po natin dyan yung web app. Kumbaga, pwede po umorder yung mga customer through apps. Pwede isang or baguhin na isang web order sa kanilang format. Ito sa number 4 po. Transporting order into common format per format. Pag umorder ka sa ordering via web per form, dun po yung process ng pag-order mo. Pero hindi po agad makaka-process kasi may mga paraan pa para mapunta dun sa number 7 or sa create new order message per form or new order creator. So number 2, ordering via call center per form. Yan po. Example po niyan. Tuwag ka sa isang company na gusto mong umorder ng kunwari, salaset. Hindi po agad makaka-process yung in-order mo pagkatuwag agad sa kanila. Marami pang hakbang para makapunta sa mismong site na tinawagan mo. For example po yun yung sa call center. Yun po yung example niya para po isa po yung example na kapag ka-order ka sa isang web, may process pa na pagdadaanan, hindi agad-agad makakapunta sa mismong tinawagan mo. Magpapasapasahan ka pa ng ibang receiver. Ordering via fax per format. Ito lang po, example naman po nito ay isa siyang app na ginagamit para makapag-order ng isang bagay na gusto mo or example po nagpag-order ng gamit or example po vlogging, cameras yun. And then yung makakapunta na po siya dito sa create mo pagkatapos yung maka-order na gusto niya order.
My name is Romel Cabrera from Team Rice. Right. Ang di-discuss ko is naman siya requirements about text orders and process. Ang first requirements is message, channel, endpoint. Yan is para siyang flowchart lamang. Okay, basahin ko muna yung integration solution. Set of patterns for the requirements. Kumbaga pattern siya para ma-achieve mo yung tamang proseso para mabasa na mabuti kung saan mo ibabato yung data. Okay. Meron diyang example na 1 and 2 na na-report na ni Eugene. Yung ordering via web or form. Yan is tumatakbo yan in a browser. Example, nag-order ka. Hindi naman agad na yung order mo. Halimbawa, image ganito. Pagdaan din sa translator, ganun pa rin. Kumbaga, hinahati-hati niya, tinatranslate niya into machine language. Bago pa lang siya Ngayon, may 3 requirements. Kailangan mag-message, kailangan niya dumaan sa channel bago pa lang siya magkaroon ng endpoint. Sa may right side yung kanyang legend. Okay. Punta naman tayo sa second requirements. Mamaya natin isiping mabuti kung paano nangyayari yan. Okay. Second requirements is ayan. Meron tayo diyang logo. Pictures. Ayan. Sa taas. Yung ordering via call center. Ito naman, example ko din is pag sinabing call center, unang papasok sa isip natin is voice. Tatawagan, ganun. Okay. Kaya dalawa lang yung requirements niya dyan. Message channel. Okay. Pag message ka, tumawag ka, tapos isa lang dadaanan yung group. Yung channel kasi parang approach yan. Pinakadaan. Bago pa lang siya mapunta sa talagang destination niya. Okay, malinaw. Ayan, yung sinasabing transform call center order ko. May dinadaanan pa kasi siyang kumbaga sa, yung kaninang sinabi ko is translator for the web. Ito naman, via call. Hindi naman agad na, tumawag ka. sa pamagitan ng parang may pa yan, third party, para bago dumating sa mismong tinawagan mo. Ayun yung tinatawag na transform call, order into common form and perform. Okay. Ayun yung tinatawag niyang translator. Kumbaga din natin is sales side yan. Ayun na yung third party niya. Okay, malinaw. Then third requirements. Ito yung mga ordering via fax. Ano naman tayo din familiar naman siguro tayo sa mga ganyan. Halimbawa, Shopee. Ayan. Basta may mga application na ginagamitan natin ginagamitan yung ordering. Yan, mali naman na hanggang di na natin discuss yung third na yan. Maintindihan natin yung Okay. Next na tayo sa port requirements. Naman, sa port requirements naman, nakikita nyo naman yung kailangan may mga translator siya. Hindi siya pwedeng walang translator. Ayan. Sa web, into cell, tapos sa application. Bago siya makapag-create ng bago siya i-perform ng or i-invoice ng isang employee. Okay? Ilang din ang requirements niya. Message channel lang naman din yung niya dyan. Tapos sa lang niya, nagkakaiba lang dyan is yung sa channel niya kasi data type channel niya. Okay, mamaya. Papakita ko na lang sa inyo yung isang develop integration solution for process ordering. Yung whole process niya. Wala na dyan yung text order, na tayo sa whole process. Kumbaga nag-buy na tayo, dito na siya papasok sa new create order message perform. Okay, diyan na papasok yun. Para mas malinaw, may nakita akong image na siguro point ako na sa'yo. Ayan. Meron din yung isang image na ordering processing to. Sa ordering, then item processing. Para malaman natin yung okay. Wala din sa new order. Diba, syempre, takes order tayo. New orders, bababa siya din sa splitter. Okay, tatanong natin kung ano yung splitter na yan. May ipapakita ko sa inyo kung ano yung ayan. Tapos, aggregator. Ito naman, tapos bababa siya sa new order ulit para sa item. Papasok naman siya ulit sa content based rows. Tapos din naman sa rows, marami siyang kumbaga, ito yung sinasabi natin if else na lang sa program. Kung tama, okay. Kung may error, i-invalid niya yung order or item na yun. Parang new attempt ulit. Tapos, i-check niya kung, halimbawa, nag-order siya ng 5 item. 4 na lang pala. Ayun, para lang sa ganung scenario. Para hindi mag ayun yung tinatawag na bug sa program natin. Yung marunong mag-check. Okay. Kaya naman natin yung splitter. Kung ano nga ba yung splitter. Para ano nga ba yung process niya, ganun. Okay. Splitter to break out the composite message into a series of individual message. Yes. Each containing data relates on one item. To one item. Okay. May example image tayo na. Okay. May order ka, 3 orders. Ayan yung green, red. Dahil sa splitter, i-divide niya yun. I-divide siya. Para sabihin niya, okay, pairing order na to. may 1 item. Tapos isang order naman to may 2 items. And yung isa, 3 items. Para hindi siya naghalo-halo. Ngayon lang naman yung speaker. Relate lang, individual series lang. Kumbaga, kung may dalawang kamukha, doon ka. Hindi ka sasama sa iba. Okay. Then next, eto, aggregator. The aggregator is a special filter that receives a stream of messages and identifies messages that are correlate. Tama ba? Okay. Ayun naman. Ito naman, sa inventory naman siya. Ini-equal niya, di ba? Halimbawa, ayan, tama. Nag-ano siya? Nag-equal. Eri yung items mo na binili. Ito yung items mo na binili. Aggregate, binabalik niya yung items. Kumbaga, di ba dalawa yun? Inventory, tapos create items. Or buy items sa pababa. Kumbaga, magsasalubong sila kung meron pa bang stock na ganere. Para i-prepare naman itong aggregator, yung order, yung inas na order ng client. Okay. Ito naman yung kanina. Point-to-point channel, ensure the only one receiver consume a given message. An adapter converts the interface of component into another interface so it can be used in a different context. Okay, point-to-point, para tong road, daan. Kung paano marireceive ng sender yung order or magsesend yung sender sa receiver ng orders mo. Kumbaga, aerially pinakamadaling way, daan. Ayun na nga yun. Para lang magkaintindihan yung dalawa. Yung sender tas receiver. Ayun lang. Next, translator, last. Okay. The message translator is the messaging equivalent of adapter pattern. Okay. Yung translator pala, ito yung nagta-translate. Kumbaga, dinagdag lang siya para magkasundo yung dalawang panig. Di ba, may incoming message, tapos para maintindihan ito. Ayun na yung sinasabi ko sa inyo kanina, yung sa machine language na tinatranslate into into message na maintindihan ng employee. Halimbawa, nag-message ka, translator, kailangan niyang baguhin yun kung paano maiintindihan. Ganun lang yung translator na tinatawag. Okay, that's all.